So we continue our discussion on what we do with our data. So previously we looked at frequency tables, how we organize data after it's collected into a frequency table. Now that is nice to have, and many people prefer to look at data in a table. Some people, and sometimes more appropriate, to display data in graphical forms, in graphs, in charts, right? What we're going to look at here is start with categorical data. That's a pie chart, bar graph, Pareto chart. There are other ones, but these are the key ones, most basic ones that you may have seen before. Pareto chart may be something new to you, but this is for categorical data. And you will see just some examples. Here is the double pie chart, and I'll let you look at our notes and you read them, right, to get an idea and look at kind of some of my comments here as we go through the video. This is a bar chart, but a double bar chart used when you're comparing two groups, part-time and full-timers, at two different categories. So you're comparing two categorical variables, right? What school you go to and if you're full-time and part-time. But you could also see it in a pie chart. So it depends. Some people prefer one or over the other. And important, we use technology to create our graphs. Okay, we'll be using statistical software, so you won't be doing this stuff by hand. You just got to know how to read them, right? And then again, this topic of choosing a chart based on data, right? Some important things highlighted. You can see all the different colors here highlighted here. And so sometimes percentages add up as you think about it, like on a pie chart, more than 100. Again, those would be rounding errors in terms of the data. But again, a bar graph is appropriate when you're trying to compare relative sizes of categories. A pie chart cannot be used in that case because pie charts only divide one group into 100%. So something to keep about again as you think about it. So you take a look at a graph like this. Notice it goes over 150%, and that's because we're comparing. We're not comparing distinct groups. Full-time students, students who want to transfer, right? They include the same amount of. They could include the same students. Each student can be in one. Or in more than one group. You can be under 25 and a full-time student. That's why that doesn't add up. But you could see here a bar graph. Notice all students 100%, and then you see the distribution here, right? Other kind of things that come up as we think about data that affects the graphs, and you'll see here is what about like missing data, right? If you don't put all the data in a graph, it tells a different story. So you could see in this example here, it shows the same information, right? But the other unknown percent, that data, the unknown percent then pops up here, and that then changes it. Do you include unknown? Like when you ask a question, race, ethnicity questions, any types of data you collect. So again, you got to be mindful of the data. Any data you look at, is there missing data? So important to have a deeper sense of analyzing data, right? And here you can see a Pareto chart as it goes from largest to smallest, just a different way. Some people want it organized this way versus this way. So all that's important to keep in mind, right? Is data sorted or is it unsorted? Is it sorted alphabetically, unsorted just randomly? Is it sorted by the values from big to small, like this one here, right? Keep that in mind as we think about how data is presented and how you read data. So again, we're going to be creating graphical displays using technology. This is just a short introduction of the types, but most important, again, it's a deeper understanding, right, of these things. The ideas of how you can be misled, the ideas of missing data, questions you should be asking, right, when you're looking at it. Does it add up to 100%? Should it add up to 100%? All of these, right? Key questions to keep in mind.